I'm going to go over the VBAI configuration that I set up for the measurement of the end clip for Cooper Standard. So let's go to calibrate image. So this is going to say we need an image, so any image will do to be able to run the calibration process. So let's just go ahead and select one of the grids. So left grid. This is just to have a valid image. So I go to calibrate image. You can see that we're using calibration grid frame. You can edit this by selecting edit. Ask for a name. Ask for expiration. And then at this point I can do add images or edit the grid parameters or edit the calibration axis. So I'm going to go into the grid parameters and notice here that I have it set up for 10 millimeter dots, and I've set up a region of interest in a certain area on the grid. I've set that the distance between them is ½ an inch, which is 12.7 millimeters. And then when I hit next, it will do the calibration and kind of tell me what the error is in millimeters, very small error, max error, very small, and so on. And you can adjust this with the slider. And then you can also add images. So I just got one image. So the more you do, conceivably, the more accurate this is. I think there's some tutorials online for doing calibration, grid calibration, and then there's also a tutorial in the help. So once this is calibrated, it's already been calibrated, then we can go into the actual measurements. So the way that these measurements are set up, so this is an actual image of parts. So I simulate an image by pulling in an image. So pulling in this image, I've set cycle through folders so that as you advance through the images, it'll advance to the next one. For a lot of these tools, it requires a grayscale image. So we use Vision Assistant to set this up. So Vision Assistant is here. So in Enhance Images, it's kind of its own program. So if you go ahead and edit, it'll open up another window. And from here, the most common tool I use is Extract Color Planes. This has already been extracted, so it's not going to let me do it again. But if I was doing it from scratch, for example, so let's say I'm just put a new one in front of this one, Vision Assistant, edit, go to color processing functions, extract color. There's a lot of different options for how you do the extraction. Hue does something kind of crazy. Saturation's really, luminance is a common one that I use. So if I do luminance, what I'll do is change the image to grayscale. It's going to warn me that I'm using a region of interest that's too small, which is fine. So now, if I look at the difference between the original and the new, you can see that it's grayscaled. So I'm going to delete that off, save, because I've already done that here. You can also do things like adjust brightness. So this one I was extracting the red plane and then adjusting the brightness. You can play around with those settings. So if I go into this one, edit, see that I've got two operations going here. One is extract the red plane. Double click that. It's really just so many options, different planes that you can select from. And that's just, visibly checking it. And then brightness. You can adjust the brightness, the contrast, and the gamma to try to make the part more black. If you really look at this. So say, really turn down the brightness. Crank up the contrast, which is going to enhance the difference between white and black. And then adjust the gamma. You can almost make it look like the part's floating in space, which is not really entirely what we want. We want edges. So let's do it this way. This really makes the part dark. And I got a nice edge. So let's go ahead and choose that. And then you got to close this window. And then say OK. So then what I did is I set up a caliper tool for the top, the center, and the bottom. And what each one of these is doing is scanning across. So the caliper is just a region of interest that scans from left and right, depending on how you set it up. And in this case, I have it catching the lines and the end of the part. Do notice that this part has a little bit of rubber hanging off of the end. And I think that the operators need to be trained to pull off any frayed material, because it'll also measure that. So actually let's pick the center one. You can see that it's scanning across and finding the very tip of the part. And it's scanning across from the right and finding the line. But the line is not real straight, so I don't know that that's going to be the best object to find. And we also see that there's a shadow based on how we set up the brightness adjustment. So I'm going to go back and adjust that again. You might notice that when you hit the edit button, nothing happens. It's actually in the background, so you might have to click over into the second window. Let's look at this brightness again. Especially when it comes to the center part, where we're looking straight down on the part. So that's not producing a good edge, so I'm going to actually change the gamma a little bit. And that's a pretty solid edge and a very black part. Let's try that. Close. Alright. Back to the center caliper. So this caliper is a little bit too large. It's going to pick up that outer edge. So if we wanted to pick up the edge of the part, we want to be inside the edge of the block, which is doable. And then you can look at some of the other tutorials as far as the settings go. Gap is somewhat wide here. The smaller you make the gap, the more sensitive it will be, and you can kind of see where the tool is sensing the difference in contrast. And you can change the edge strength. You can also just slide this up to say this is the strength of, or the difference in contrast I expect. And then smoothing will kind of smooth all this out. And the lower the steepness, the better, really. One alternative to this way of doing things is to use edge finding instead. So if we're going to use edge finding, let's just say we want to find the distance from the left edge of the blocks to the tip of the part. I would set up, so I'd go to locate features, and I would find a straight edge. So draw a region of interest over here on the left, and we're going to go from left to right, and we're going to go from dark to bright. Let's do it that way. So there's some shadows here. And then it's best if you leave it in auto setup. And then choose best edge. But you can always take this out of auto setup and based on your histogram, jack with the settings. Gap is kind of a big one. So you can lower the gap. And now we found an edge over on the left side of the part, or left side of the block. Let's do the same thing for the part itself. So notice we can rotate this so that's scanning across. And so let's say we want to, let's go right to left in this case, and we're going to go from dark to bright. I want to find the best edge. And let's crank down the gap a little bit. Let's make that 5 as well. The bigger I make the gap, the more general this thing gets. So I'm going to go actually back to auto setup. So that's kind of cutting off the end of the part. One option would be to shrink that up. Finds a better edge. So question is, how do you measure from a line to a line? You really don't. So we need one more edge here. So let's find the top edge of this part. So back to settings. Let's go from top to bottom. And let's go from, let's try dark to bright. We're seeing we're picking up some shadows here as well. So first thing I'm going to do is expand this. Cover more of the entire part. And I'm going to do a best edge. I'm going to reduce the gap. Still picking up that shadow. You can see our edge profile is not real great. So let's think about other ways that this can be resolved. One thought would be to find the top edge of the block. It's one option for sure. You can also go bottom edge. That one seems a lot more crisp. But that's really not the point we want. We want this point up here. We want to find this point. So let's shrink this up a little bit. I'll zoom in. Oh. Let's redraw that area. Let's go bottom to top. It's looking better. Okay, so let's leave it there in auto. Auto is much auto you can do, the better. So really, we just want to find this point, and then we're going to measure from this point over to the edge. So, in order to generate basically a point, you go into measurement features and go to geometry, and call this find part corner. And then we'll add a feature, and we're going to make this a intersection. So line intersection. And then at that point we need to pick two lines. So we're going to pick these two last straight edges that we set up. Okay, and that should just generate a point right here at the end of the part. Alright, so we found the part corner, it's right here. So we're going to then go ahead and do another geometry. So we'll call this project to block edge. And this is a perpendicular projection. So there is a way of measuring between two lines with midpoint distance, and that's really not what we want. So we're going to do projection. And it wants 3 points. You notice that's 1, 2, then 3. So our third point should be the corner point that we just found. You'll notice that's right at the corner of the part. And then the other 2 points should be the edge of the block. Alright. Oh. So that's good there. Now these 2 points are the edge of the block. So see if that automatically fills in. Yep, it automatically fills in. Alright, and then this gives us a distance. So the distance from projecting this point perpendicular to the edge of the block is 2.46 millimeters. Now, zoom out a little bit. To get a view of what this is doing, and it's really not all that clear because these red lines are representing edges found and also the caliper measurement. So this makes it a little bit hard to see, but you can kind of see if you zoom in here. We're measuring from this crosshair to this crosshair. One of the ways that you can somewhat easily visualize this is to use the overlay tools. So I think that I can use a custom overlay in this case. And it's going to ask you to keep the existing overlay. Sure, that's fine. We'll call this overlay measurement line. And we're going to create a line. And we'll kind of just draw this line from this point to this point. And let's change the color on this. Let's make it yellow. And let's make it really thick, so it's pretty easy to see. I just drew that on the image, but we can select an end point and a start point. So one would be projecting the edge, and the other one would be finding the corner. Alright, so no offsets. And then this gives us a little bit better idea of what kind of measurement we're making. So just for visualization purposes. So then, if we wanted to, so currently I have this calculator tool that's doing some offsets. So I go into the calculator tool and I select edit inputs outputs. I'm on the input measurements tab. It'll show me what I'm using. So top, center, distance. So this is currently using the calipers, but I must switch it over to using the edge finding. Alright, so we're going to uncheck the center one for distance, and instead we're going to select the project to edge, and we're going to use the calibrated distance instead. So when I do that, it's going to disconnect the original input. So here I could add an offset. So say I found that the center measures 2.5 under nominal to the edge, and the top one is 2, then I would want to add a 0.5 millimeter to the final measurement. So if I go to measurements, I can do a calculate. The measurement was around 2.5 for the center in, and I'm adding 2.5 to it, so the result is 5. And the final part of this is that, you can set this up however you want and then log the data. So if I go into the logging, you can see that my destination is going to store a CSV file, so a spreadsheet file basically, to something called log clip measurements, to this directory. It's just going to store a single file, and if I check the overwrite, it'll overwrite it each time. Otherwise, it'll just keep appending to it. So here's where I can select the measurements. I'm selecting the image name that's actually considered a measurement, and then at the calculator step, I'm selecting the 3 measurements that I'm doing. So let's back out a little bit. I'm going to save this, and I'm going to run it. So if I have this on the current image, I can run it once by hitting the little run button, and it runs once. And then if I go to that folder where the spreadsheet is stored, you can see I have a CSV file, which I can open with Excel, or I can open with Notepad, but with Notepad it's pretty hard to see what's going on. So I just ended up opening it with Sheets instead, and you can see that it tells me which iteration, and then each time that you run the configurations from scratch, it's going to put down this header information. So it tells me my measurement information for each. So this is the serial number, and then the measurements for each. Something's not right here because this one should not be 59 at the end. So let's go back and recheck what we're using for our measurements. So expand the calculator step. Should be good. Center clip final measurement is what it should be using. So let's go look at that again. So it is outputting the wrong information. Must not have saved. So let's do this again. Let's edit the inputs. So for the center, we're not going to take the caliper. We're going to take instead projected block edge, calibrated distance. reconnect that. Say OK, save, and then we'll run the same image over again. And then we'll go ahead back to Chrome, go to Sheets, Alright, so now for the center, we're seeing this 5mm. And what else I would like to, so this is how you adjust things. I think in the end, this is going to be more accurate than using the caliper. So we probably want to shift all this over. And what we're trying to do is determine when you run one part to the next, how much that distance changes, assuming that the parts are loaded properly. So what I'm going to do here is advance forward in the set of images, and I'm going to hit this button to continue to run inspection in a loop. So just go through the images one after the other and do the measurement. We're seeing that line's tracking okay, but in some of them it's not quite right. So really what you'd want to do is do this one by one and adjust. So run it, run the next, run the next. Now we can see that this one's a little bit off. So the left edge of the block, that's looking very consistent. Let's see what this looks like. Zoom in a little bit. That looks good. That looks fairly reliable. This one is a little bit off. Let's try to adjust the gap a little bit. Let's actually really reduce the gap down. Let's take it to 10. Something like that. That looks better. But this is the process, going through all these. So let's go back and look at our file again. I don't know why I'm closing that every time, but so back to Sheets. And you're probably better at this than I am. Maybe there's a way of linking to the local file. So now, because I ran this continuously, there's lots of measurements. So then once we're in the spreadsheet, we can do things like find the average, find the max, min. Let's actually just copy this. And we can see that we have a pretty large difference between these two, and it's probably because of the way it was finding edges. And standard deviation is really